Hi, I'm Ciaran Connell, the former CEO and co-founder of Decawave, and now the General Manager of the Ultra-Wideband Business Unit at Qorvo. Thank you, UCD, for this distinguished graduate award, awarded to me and Michael jointly. You ask, what does it mean to me? Well, I ask you this. If a tree falls in the wood and no one is there to hear it, does it make a sound? If a technology is developed in a lab and never makes it to market, does it make an impact? Those are the important questions for me. To the former, yes, it makes a sound. To the latter, no, the technology does not make an impact. Stanford University pioneered commercializing technology developed in their labs, and UCD, via Decawave, has done the same. We commercialized a breakthrough technology, impulse radio ultra-wideband, a technology pioneered by McLaughlin and developed by the team we built, and just as important, commercialized by the team I built. From the IEEE ratification in 2007, to the first mass production in 2013, to the launch of our second family of parts, we raised in excess of 65 million euros from 250 plus angels worldwide, and best-in-class VCs, notably Atlantic Bridge and ACT, and of course, chaperoned throughout by Enterprise Ireland. We exited with a trade sale to Qorvo, with every single investor making money. And when we started Decawave, I had three goals. One, that every investor makes money. Two, that the technology becomes pervasive. And three, that the technology employs 100 plus engineers with meaningful jobs in Ireland. There are two ways of doing that, an IPO or a trade sale. As you know, the semiconductor industry is very, very capital intensive. A trade sale was the prudent choice, and when we did so to Qorvo, all three objectives had been made. And so this award recognizes the importance of developing and commercializing the technology. Mission accomplished.
Hi, I'm Michael McLaughlin, former CTO of Decawave and now Senior Fellow at Qorvo. I've always wanted to be an engineer. I've wanted to be one long before I knew what an engineer was. At the start of secondary school, our teacher asked everyone what they wanted to be when they grew up. I said I wanted to be an inventor. Many of the boys in the class said they wanted to be engineers. I didn't know what that was and had to ask around. I didn't get very clear answers. But for me, at least, an engineer is an inventor, a professional inventor. Like most engineers, I was always intensely curious and had all the grown-ups I could find tormented with never-ending questions about how everything works. Even now, my wife is forever saying, "Why do you always have to know all the nitty-gritty?" So naturally, I've always loved science and maths. Do I love them for themselves, or do I see them as tools to help me invent things? I'm not sure. When I was about 15, I built a prototype 3D camera and projector out of white plastic paper and an empty plastic container with a slit in the bottom. This didn't produce a stereoscopic image like you get with so-called 3D movies, but an actual 3D image where you could move your head and see a different view of the scene. I went into the patent office to see if it had invented before. I couldn't find anything, but I knew that electronics weren't fast enough at the time to do this in a real product. Maybe it would work now. With two friends at Oatlands College, when I was 16, we set out to explain a phenomenon that was popular at the time known as Kirlian photography. It was supposed to be able to photograph your ethereal aura. We explained that what was going on was an interaction between the photographic film and the high voltage sparks that were used to generate our aura's image. We entered the Air Links Young Scientist competition with our experiments and our explanation, and we won £100 for first prize in the senior group section. The three of us went on to engineering in UCD with three other Oatland College classmates. This was the largest contingent in the class from any school in Ireland that year. At UCD, my love affair with computers and electronics blossomed. The year I graduated, 1982, was not a good year for jobs in Ireland. And I was one of only a handful of graduates not to emigrate. I stayed in Ireland and spent nearly 2 years painting and decorating in Donegal with my uncle Dewey. My first electronic engineering job was in Cornell Electronics and the first product I designed was a 300 bit per second modem. While at Cornell, we collaborated with Professor Tony Fagan's DSP group at UCD and came out with the world's first V32 chipset, which communicated at a breathtaking speed for the time, 9,600 bits per second. We, Cornell, with the help from the DSP group from UCD, then became involved with the ITU, and I helped to define the V34 dial-up modem standard, which would run at 4 times the rate, 28.8 kilobits a second. I got to collude technically and go for pizza with men who were legends in communications and signal processing. Men like Gottfried Ungerbeck and Dave Forney. I was there for 18 years and we continued to push the boundaries of technology. I spent 2 years at Parthas, where Dave Maloney got me interested in ultra-wideband radio systems. Parthas were taken over by another company, Seva, whose focus was digital signal processors. I fundamentally believed that ultra-wideband was going to become a very big thing. So I started Decawave in March 2004. I attended IEEE standards meetings where I managed to persuade the 200 or so world expert engineers involved that they should do the 3 main communications components in the ways that I had conceived. They saw that I was right eventually, and in 2007, the 802.15.4a standard was published. At this point, I got back to my old college classmate, Ciaran Connell. When we had graduated together, after the ceremony, we were both outside Belfield Bar with a pint, and we made a pact that one day soon we would start a company and he would do the business end of things and I would do the technology. Now was the time, I said to him on the phone. I told him that I persuaded him that this was ultra-wideband was going to be huge and would end up on every mobile phone in the world. He agreed to be CEO, and Decawave became an IC design company in July 2007. We started to raise money and hired some exceptionally smart engineers, many of them UCD graduates. 2 years later, we got our first prototype working. It was about the size of a cereal box. 2 years after that, we had our first prototype microchip. And in 2013, we went into production and started mass producing. A Decawave microchip sends out a series of very short pulses over the airwaves. Each pulse lasts for 2 billionths of a second. Another Decawave IC receives that and measures the time it arrives to the accuracy of better than 1/10 of a billionth of a second. By measuring to this accuracy, you can calculate the distance between the chips to about 2 centimeters precision. Decawave spread the word, got more than 3,000 customers, and sold more than 10 million ICs. Our ICs have been standard equipment in every new Jaguar or Land Rover since 2017. We managed to persuade a very large US mobile phone manufacturer that mobile phones needed to have this technology, and they designed their own chips so that now all new phones produced by that company have had their ultra-wideband IC in them since 2019. All the other major mobile phone companies have either already followed suit or are just about to do so. On Friday, the 21st of February, 2020, the Friday before the US stock market started its 35% crash, the US microchip company Qorvo acquired Decawave, which is now a team of 80 engineers, for a rumored $400 million. The most valuable Irish tech acquisition ever. Unlike many Irish tech acquisitions, Qorvo have continued to invest heavily in the Irish operation and allowed us to steer our own course all the while. Believe me, this is just the start. Given that there are more than 5 billion smartphones in the world, and that each smartphone will be using ultra-wideband to connect to cars, laptops, car keys, remote controls, payment terminals, other phones, wallets, etc., etc. It won't be long before there are more UWB ICs than people on the planet. Ciaran and I are extremely honored to receive the EGA's Distinguished Graduate Award. I believe it has been awarded jointly for the first time, which makes it all the more special and underlines the poignancy of the journey we jointly conceived of taking back in 1982. Thank you very much, everyone.